Now, good day. Welcome back to our Plus One tutorial. Now, today too, I'm coming to explain the continuation of trigonometry ratio. So pay attention carefully and then let's move on. Okay, I'm going to talk about complementary angles. Please, if today is the first time you visit my channel, make sure you tap on the subscribe button, then you leave some few likes and comments in the comment section. Thank you. Now, complementary angles. Now, when we say complementary angles, what does it mean? Now, complementary angles are two angles that add up to 90 degrees. Add up. I'm saying either add up or sum up to 90 degrees. So anytime we have two angles that add up to 90 degrees, we consider angles as what? As complementary angles. So let's talk about some angles that we can add up to 90 degrees. Now I can consider 0 and 90. 0 degrees and 90 degrees. Now, these are complementary angles. Now, 1 and 99 degrees. Complementary angles. Why? Because when I add 0 to 90 degrees, I'm going to get 90. If I add 1 to 99, I'm going to get 90 degrees. And these angles are complementary angles. Now, I can talk about 30 degrees and then 70 degrees. Yes, I can talk about 80 degrees and then 10 degrees. Now, these are examples of complementary angles. Two angles that add up to what? 90 degrees. We consider those angles as what? Complementary angles. We consider those angles as complementary angles. So as I'm coming to explain complementary angles, just look at it and then let's see how we can derive it. In this video, I'm coming to derive a little bit about complementary angles in terms of trigonometry ratios. And then after that, I'm going to solve an expressions containing complementary angles. Then I will solve equations containing complementary angles. I'm going to do three things here. One, prove complementary angles. Two, I'm going to solve expressions. Three, I'm going to solve equations. So follow me closely. This one is just to give you understanding about trigonometry. This one is a plus one tutorial. Make sure you share. Now let's look at it. Now let me consider a right angle triangle. Hold on for me. Now let's consider a right angle triangle. Now if I have a right angle triangle like this, now so with this particular right angle triangle, this angle is 90, right? And then interior angle of a right angle triangle, when you add all the angles in the right angle triangle, the interior angle, sum of interior angle is 180 degrees. So if this particular angle is 90, then it means that this side plus this side, this angle plus this angle should also add up to what? 90 degrees, right? Okay, fine. Now, the first thing, if I consider this particular angle, if this angle is x, then what will be this angle? Then this angle can be, because here and here add up to 90 degrees, then I can consider this side as what? As 90 minus x, right? Okay, now let me consider this one as y. Now don't forget that if I add x plus y, it's supposed to give me 90 degrees. Why 90? X plus y plus here supposed to give us 180. When you group like, it's going to get here plus here to be 90, right? Because here is already 90 degrees. So when you add the interior angle, is going to give us 180 degrees. I don't want to go through that process. So since here is 90, then here plus here should also give us 190. Now with this particular one, you can make it as the subject or y the subject. You can see that the moment I make as the subject, I'm going to get 90 minus x. the moment I make x the subject here, I'm going to get what? 90 minus y. Now, so any of them is correct. Don't forget, any of them is correct. Any of them is correct. Yes. Now let's put this one aside. Now, I can look for the Pythagoras theorem. Now, let's consider the trig ratio, the first trig ratio. I'm going to find all the trig ratios, then we see how we can compare them. Yes. Now, with this one, if I consider the angle x, this side will be the opposite. Then this side will be the hypotenuse. Here will be the adjacent, right? Yes. Now, let's find sine of the angle x. Now, don't forget that sine is so. Don't forget that sine is so, and so means opposite of what? Hypotenuse. Go and check our previous video to know more about this. Now, it is opposite of what? Hypotenuse. Right? Now, let's look at something here. Now, too, let me find cos of x. Let me find cosine of x. Now, what's the cosine of x? Now, cosine of x will give us what? Opposite. Cosine will give us adjacent. The adjacent over the hypotenuse, right? Adjacent over what? The hypotenuse. Okay. Now, let's consider tan of x. And what is tan of x? It is opposite over what? Adjacent. It is what? That is the opposite over the what? Over the adjacent, right? Now, this is what we mean by the SOHCAHTOA. This is what we mean by the SOHCAHTOA when we consider the angle x. Now, when we consider the angle y2, here will be the opposite hypotenuse, then here becomes the what? The adjacent. You get it? Yes. Now, this is what you're supposed to know. Now, if I'm going through this one, I'm going to move with a high speed. So, look at what I'm going to talk about right now. Now, pay fully attention. Now, let's go into details now. Now, in the first place, don't forget that we've talked about this one. Now, let me come and prove all of them here. Now, let me use something to represent the hypotenuse. Now, let's say this part is M, here is N, and then this side is Q. This side is Q. Now, let's solve for sine. This one is from SOHCAHTOA. Now, let's solve for sine. Now, sine x. What is sine x? It is the opposite over the hypotenuse. So, it will be N over M. Right? Okay. The opposite is N. Hypotenuse is M. Now, let me find cos x. Now, cos x is adjacent over hypotenuse. Now, the adjacent here is Q. And then the hypotenuse here is M. Now, let's solve for tan x. Now, what is tan x? Tan is 2 opposite over adjacent. Now, the opposite here is N. Now, the adjacent here is what? Is Q. Now, this one is in terms of the sine x. Now, let's find the angle in terms of y. Let's look for the angle in terms of y. Now, first, let me solve for sine y. Now, the moment I consider this angle, then it means our opposite become the Q, and then adjacent become what? The N, because I want to consider the angle QXAY. If I consider the angle Y, then this one becomes our opposite, this side becomes our adjacent. The hypotenuse remains the same. So let's solve for Y, sine Y. Don't forget sine Y is opposite of what? Hypotenuse. Now what is the opposite? The opposite is Q. Now what is the hypotenuse? The hypotenuse is still M. Now let me find cos X, cos Y. Now so the same cos is adjacent over hypotenuse, right? Now the adjacent here is N, and then the hypotenuse here is M. Now let's solve for tan Y. Tan is 12, opposite over adjacent. Now what's the opposite? The opposite here is Q. Then the adjacent here is N. Now let's compare this one to this one. Can you see that the sine X here is N over M? Sine X is N over M. Now compare this one to this one. Sine X is N over M, and then sine Y is also N over M. So I can boldly say that, or we can all agree that the sine S is now the same as what? Cos Y. And they are all N divided by what? M. Now this is what we call complementary angles. So this is the first one. So sine X is given as the same as what? Cos Y. And they are all N over M. N over M, N over M. Now the same way, if you look at the cos X here, cos X here is Q over M. Is Q over M. Can you see that the same as what? The sine Y, which is Q over N, M. So the same as sine Y, which is, they are all Q out of what? M. Now we see what we are deducing here. Now what we are deducing here is that when we have a complementary angles and it is sine, you can change the sine to cos of a different angle. If you have the cos, you can also change the cos to what? The sine, right? Yes. Now this is the first thing you're supposed to know about cosine and what? Sine. Now let's look at something. In our first deduction, don't forget that this x plus y is equal to 90 degrees, right? So the moment I make s the subject, s is 90 minus what? Y. X is 90 minus y. And the same way, y is equal to 90 minus x. When you make either the s or y the subject, this is what we're going to get, right? Okay. Now let's look at something here. Now this one means that if I have sine x and I want to change the sign to cosine, I can just write cosine of y. Now what is y? Y is the same as 90 minus x. Y is the same as 90 minus x. So the y is 90 minus what? X. Now what is x? X is the one here. You get it? So for example, now I'm teaching two things here. Look at it very well. The first thing is that since x plus y is equal to 90, and then this statement is true, it means that any angle here and any angle here, this x plus y, when I add them, I'm supposed to get 90 degrees. It confirms that this one is also true. Now the second thing is that when I take sine x equal to cos y, sine s equal to cos y. Now what is y? From here, y is 90 minus what? X. It means that anytime I have sine of any angle, let's say sine 30 degrees, and I want to change this sine 30 to cosine, I just have to write cosine is equal to 90 degrees, then minus the x. What is x? X is the 30. It means that sine 30 will give us cosine. What is 90 minus 30? 90 minus 30 is 60 degrees. Don't forget that the y here becomes 60 and the x here becomes 30, meaning the moment this side is 30, here will become what? 60. And these two things are complementary what? Angles. Now this is what I want you to know. Yes. So the moment I have sine of an angle, I can convert the sine to cosine by subtracting the angle from 90 degrees. Now the same way, if I consider the cosine, don't forget the cosine of x is the same as the sine of what? Y. Right? Yes. Now, the same way, if I consider cosine of x, now what is sine? I want to change the cosine to sine. Now, what is sine? What is y? Y is 90 minus x. So, y is 90 minus what? X. Now, the same way, I can write everything in terms of y. Yes, I can make the x the subject, write everything in terms of y. Now, look at it very carefully. Now, it means that anytime I want to change the cosine toward the sine, I have to subtract the angle of the cosine from the sine, from 90 degrees. Now, so it means that if I have cosine of 20 degrees and I want to change it to sine, I have to subtract the 20 from 90. Don't forget the x is 20, so I'm going to get what? 90 minus x, the x is 20. So we have cosine of 20 degrees equal to sine of what? 90 minus 20 is 70 degrees. I hope you can see it clearly. Just pay attention and open your eyes and then look at it very well. Now, so sine 20 is the same as what? Cos 20 is the same as what? Sine 70. Why? Don't forget that the 20 plus the 70 will give us what? 90 degrees. So they are complementary what? Angles. They are complementary angles. You get it? Yes. Very good. Now, thank you for understanding this particular concept. Now, I'm going to use this one to solve two questions here. Two sets of questions. Two different sets of questions. Now, before then, let me talk about the other trig ratios. That one is mostly related to relative math students or those doing additional mathematics. So this one is just for core math. Now let me dive into relative math more. Then I'll look at the other trigonometry ratios. Now let's look at something. Now I'm going to base on this particular understanding here, and I'm going to continue because I've trained this one. Now let's move on. Now, so the first one is that anytime I have sine of any angle and I want to change it to cosine, I have to subtract this angle of the sine from 90 degrees. I'm going to get cosine of 90 degrees minus the angle here, x. That is our first statement. Now, let me talk about the second one. Now, 2. You remember cot of any angle. Don't forget that cot or cosine of an angle is the same as cos x divided by sine x. Right? Don't forget. And then don't forget that the tan theta or tan of any angle x is also the same as what? sine x over what? Over cos x. I think we talked about this one in the previous video. Now I'm going to look at the difference between these two things, whether they are also complementary. Now, tan of any angle x, cos of any angle on x. Now, what is tan x? What is tan x? I want to talk about the difference between this one and this one. I want to also talk about the fact that, okay, let me say tan y. Let me talk about their different angles. Cot x and then tan y. Whether these ones are complementary angles. Now, don't forget sine is the same as, the tan is the same as sine x over cos x. Now, let's come to the cot. Cot is the same as what? This one is in terms of y. So, it's going to give us what? Cos y over sine y. Now, don't forget that per our deduction, the y is the same as what? 90 minus x. Don't forget y is the same as 90 minus x. So I'm going to get something like sine x over cos x is the same as cos of 90 minus x. Don't forget y is x. Now all divided by sine of what? The y, which is 90 what? Minus y minus x. It means that if I convert this particular cot y in terms of the angle, changing the y, I'm going to get what? I'm going to get here to be cot y. Y is 90 minus x. You get it? Yes. Now, what can we say here? Now, are you seeing sine x? Are you seeing sine x equal to what? Cos 90 minus x? And then cos x equal to what? Sine 90 minus x? Yes. Now, this thing here shows that this tan and then the cot are also complementary what? Angles. The tan and then the cos are also complementary angle. Since sine x will give us the cos of what? 90 minus s, and then cos s will also give us the sine of what? 90 minus s. It proves that this one and this one are also what? Complementary what? Angles. Complementary angles. Because I can do some deduction, then we do cancellation here and there. Yes. Now, I don't want to go into that particular cancellation, but I want you to see something. Now, so it means that whenever I have tan x, it's also the same as what? Cot y. Y is 90 degrees minus what? X. So cot and then tan are also complementary angles. Now, let me talk about the cosec of an angle x and then the sec of an angle y. They are also complementary angles, right? Yes, they are complementary angles. Now, let me express all of them in terms of x. Now, don't forget that, okay, now let me change it so that it will go according to this one, the same thing. Now, let me bring the sec first. Now, sec of an angle is the same as cosec. Okay. Now, whether you change it, you're going to get the same answer because sec, but I want to move with sine and then cos so that I'm going the same thing as this one. So let's say cosec of an angle x the same as what? Sec of an angle what? Y. Now this cosec and then sec are also complementary angles. Yes. Now let's look at it carefully. Now don't forget that the sec, the y is the same as what? The y is the same as 90 minus x. The y the same as 90 minus x. Don't forget. Yeah. Now what is cosec? Cosec is 1 over sine x. Now, what is sec? Sec is 1 over what? Cosine. Cosine. Now, when you do cross multiplication, what are you going to get? You're going to get this one multiply this one. You see, when this one multiply this one, I'm going to get the same thing. When this one multiply this one, I'm going to get the same thing, right? So it means that cos of 90 minus x is the same as sine of what? X. Now look at this. How do we call this one? They are complementary angles, right? Yes. So it means that the complementary angle is not limited to only sine and cos. Tan and then cos are also complementary angle. You just have to subtract. If you want to change sine to cos or cos to sine, subtract the angle from 90. But don't forget the two angles add up to what? The two angles add up to 90 degrees because they are complementary angles. Yes. Now, so these ones are all complementary what? Complementary angles. Yes. Okay, let me. So these ones are all complementary angles. These ones are all complementary angles. Now let's see how you can apply complementary angles to solve questions. Now we are going to solve the questions here. Now question number 1. Now we are to find the value. Of. Now I'm going to solve these two questions. 2 sine 20 divided by 3 cos 70 minus cos 54 divided by 2 sine 36. Now B. I am going to solve this one. Sine 20 divided by cos 70 plus cos 25 divided by sine 65. Now I'm going to solve these two questions. Now solution. Now let me consider the first one. Now looking at sine 20 and then cos 70. Now these two angles are not special angles. You get it? They are not special angles. Now so first, you can either change the sine to cos. What do you have to do when you are solving questions like what you have to do is that you have to simplify the question in such a way that the sine and sine will cancel, the cosine and cosine will cancel. So you are the one supposed to control the question. Now, so with this particular question, what I can do is that I can change the sine to cos, or I will change the cos to sine. Then from here, I can change the sine to cos or change the cos to sine using complementary what? Angles. Now, so first, let me talk about sine 20. Now, don't forget that I can change sine 20 to cos. So it will be cos of what? I need to subtract this 20 from 90. So 90 minus what? 20, which will be the same as cos what? 70. Now, so it means that sine 20 is the same as cos 70. So I'm changing this sine to cos. Sine 20 the same as cos what? 70. Now, when we come here, we can also change any of them. Now, let me change the cos rather to sine. Now, I'm going to change cos 54 to sine. How do I change this one to sine? I need to subtract this one from 90 degrees. So the same as sine 90 minus the angle 54. Don't forget. Now subtract 90 from 54. 90 minus 54, what are you going to get? You're going to get 36. So this one is the same as sine what? 36. You see how simple it is? Now, so if I'm looking for A, which is 2 sine 20. Don't forget that sine 20 is the same as what? Cos 70. Divided by 3 cos 70. Now, why did I change because I have cos 70 cos 7 so that I can cancel out. Now minus, what is cos 54? Cos 54 the same as what? Sine 36. So I'm going to get sine 36 here divided by 2 sine 36. Now, so what can we do here? Cos 70 will cancel cos 70. We're going to get 2 out of 3. Now, minus sine 36 will cancel sine 36. I'm going to get 1 out of what? 2. Then at this point, we can now find the LCM of 3 and 2, which is 6. 3 going to 6 2 times 2 times 2 will give us 4. Now 2 going to 6, how many times? 3 times 3 times 1 will give us 3. So what are you going to get? The answer will be 1 out of 6. You see how simple it is? You need to convert them to complementary angles so that some will cancel that. Otherwise, there is no way you can solve this one. Don't forget, these angles are not cool. They are not special angles. Now let me solve the second one. Let me solve the second one. Now solution. Now, so with this one, I can convert the sine 20 to cosine, or I can convert what? The cosine 70 to what? Sine, right? Okay. Now, you can even go straight away. Okay, so let me say sine 20 is equals to what? Convert this one to cos, I'm going to get what? Cos 70, right? Why cos 70? We subtract the 20 from what? The 20 from the 90. So let me say 90 minus 20 cos what? 20. Cos 70. Now, let me convert this one to, it depends on the one you want to I want to convert sine 25. I want to convert sine 65. Then it will give us cos what? I will subtract this one from 90. So 90 minus 65. And then we're going to get cos of what? Now subtracting 90 minus 65, we're going to get 25. So this is how simple the complementary angle is. So if I have sine 20, what is sine 20? Sine 20 is the same as cos 70. So I'm going to get cos 70 divided by what? Cos 70 plus cos 25. I didn't change cos 25, so I still have cos 25 divided by, now I rather change this one. I change the sign rather to cos. Sine 65 the same as cos 25. Now what's going to happen here? Cos 70 will cancel cos 70, so we're going to get 1 over 1. Now cos 25 will cancel cos 25, we're going to get 1 over 1. So the whole answer for this one will give us what? Will give us 2. I hope it's simple. Now let's dive into equations. That is going to lead us into complementary angles. Now let's look at the equations. Now let's solve this particular question. Now we are to evaluate cos 2 theta plus 10 equal to sine 18. Given that theta is acute. Now 2, find y if sine 5y, okay, if y squared minus 20 equal to cos 3y plus 50. Then I'm going to talk about the last one. If sin 5x minus 25 is equal to cos 70 minus 2x, where x's are cubed, find x. Now let's look at this little question. I'm going to solve this one fast, then we go. Now solution. Now at this particular point, I'm going to use two methods to solve for this particular thing. Now don't forget that we have cos of 2 theta plus 10 equals to sine theta. You see, there is no way we can solve for the angle theta because this one is cosine, this one is what, sine. Don't forget that we have talked about it previously about how we can find the cos inverse and the sine inverse and those things. Yes. Now, so what can we do here? Now, question 1, I have cos 2 theta plus 10 is equal to sine 18. Now, let's look at method 1. Method 1. Now, method 1, what I'm going to do is that I'm going to change the sine 18 to cosine. Now, let me change sine 18. Now, sine 18, how do we change sine to cosine? We have to make sure that these two angles are the same. We have to make sure they are the same. Yes. These two sines are the same. The trig ratios are the same. Now, so sine to cosine, I need to subtract the angle 18 from 90, right? Now, so 18 minus 90. Now, when you subtract 10 from 90, you're going to get 80. When you subtract 8 from 90, you're going to get 72. So this one is the same as cos 72. Cos 72. I hope you understand, yes. Now, so it means that cos 2 theta plus 10 is the same as sine 18. Sine 18 is the same as cos 72. Cos 72. You see how we are applying? It's very simple. Now, don't forget that here is cosine, here is cosine. Cosine will cancel cosine. Or when you multiply through by cosine inverse, when you multiply this one by cosine inverse, you're going to get 1. So it's going to be left with the angle 2 theta plus 10. When you multiply here by the cosine inverse, you're going to get 1, which will give us 72. You get it? So multiplying through by cosine, we are going to get the angle here, which is 2 theta plus 10 is equal to 72. At this point, you can easily solve for the angle theta. So I'm going to get 2 theta is equal to, I have 72 here, you group like terms. So we have 72 minus 10. 2 theta, I hope you are following. So we're going to get 62 degrees. Now theta will give us 62 degrees divided by 2. Theta, now 2 going to 6 3 times, so we're going to get 31 degrees. And you know 31, this one is an acute angle. Follow me closely. I hope it's simple. So you have to just change one of the angles to what? One of the trig ratios to a different trig ratio. Make sure the trig ratios are all the same. Don't forget that you can also change this one to sine rather. If you want to change this one to sine, you subtract this one from 90 degrees. You get it? But it's simple to this one. That's why I focus on this. Now, another way we can solve this, method 2. Now we have cosine. Don't forget that we had sine x is equal to what? Cos y. Cos y. Now don't forget this in our previous way. Now don't forget that we had sine s is equal to what? Cos y. Don't forget this particular statement, right? I hope you've not forgotten from the beginning, yeah. And then you remember that the x plus the y, that is the angle of the x plus the angle of y was what? 90 degrees. Because they are acute and they are complementary angles. So the angle of the sine and the angle of the cosine, because they are acute angle, they are complementary angles. When you add this, will give us what? 90 degrees. I'm going to apply this particular strategy. So I have cosine of 2 theta plus 10 equal to sine 18. So what I'm going to do is that the angle here, that is 2 theta plus 10 plus the angle here. Don't forget that this one is the x, this one is the y. You get it? So when you add the angle of the cosine and then the angle of the sine, they are complementary. You're supposed to get 190. We're supposed to get 90 degrees. So the angle of the sine is 18. When you add the angle of the cosine and the angle of the sine, it's supposed to give us 90 degrees. When you add the angle of the sine and the angle of the cosine, you have to get 90 degrees. So I want to use this approach. So I'm not going to change any of them to sine or what? No. Now at this point, I can say that 2 theta plus 10 plus 18 will give us 28. It's equal to 90 degrees. So I'm going to get 2 theta is equal to 90 degrees minus what? 28. Now 2 theta will give us what? Now we are going to get 62 degrees. They're going to get 62 degrees. Then theta will give us 62 divided by 2, which is 31 degrees. The same as this. So we have two methods we can go through. We look at it, we add the two angles directly equal to 90 degrees, or you change one of the angle to what? Another angle. Now let's solve question number 2. Now, so with the same concept, question number 2, we have this. Now, don't forget that x and y, they are acute angle. Now, question number 2. Now, so we have sine y squared minus 20 equal to what? Cos 3y plus what? 50. Now, it depends on the method you want to use, right? Yes. Now, which method should I use? I can use either first method or second method. Now, let me use the first method. After that, I'll use the second method too. So, I'm going to have sine y squared 20 is equal to, I want to change the cosine to sine. I'm going to change this one. How do I change it? I have to subtract the angle 3y plus 50 from 90. Then I will change it to what? The sine. So this cosine, okay, now let me do it. You can either change this one or this one, but I prefer changing this one. Now I want to change the cosine of 3y plus 50. Now I want to change it to sine. Then it means that I need to subtract this angle from 90. So I'm going to have 90 minus the whole of this angle. This angle is 3y plus 50. I hope you understand. Yes. So if I want to continue, I'm going to get sine y squared minus 20 is equal to cos this. Don't forget cosine of this one, the same as what? The same as the whole of this. The same as sine 90 minus 3y plus 50. Now this one, you can even expand it before you do whatever I want to do. Yeah, but the board is too small. I don't want to expand it. Now, at this point, when you find the sine inverse, the sine and sine will cancel. We are going to get only the angles. We're going to get y squared minus 20 equal to the angles here. The angles here is 90 minus into brackets 3y plus 50. You understand? Yes. Now let's just, we're going to get y squared minus 20 is equal to 90. Negative times this one get negative 3y. Negative times this one get negative what? 50. I'm going to get y squared. Now, since I have y squared, let me group all of them to one side of the equation. Now, this one, I'm going to get 3y. I'll have minus 20 here. Minus 90 plus 50 is equal to what? 0. So y squared plus 3y. Now this one is the method of grouping of like terms. Yes. Now this minus 20 plus 90 will give us minus 110 plus 50. I'm going to get 60. So minus 60 degrees is equal to 0. Now at this particular point, you can just factorize it to get a value of y. Yes, you can factorize to get a value of y. I hope it's so simple, right? Yes, this one is so simple. Now, so should we go further? Now, which two numbers are you going to use? Now, 60 times what? That will give us 60 will give us what? So you can just look at the factors you are supposed to use. Yeah. So the factors I'm supposed to use. Okay, I think this one is giving us a complex root. Now, since this one is giving us a complex root, you can just solve the answer. Either using, I'm not coming to teach a quadratic here. Now, this one will give us a complex root. So solve it to get the answer. Yes. Solve it nicely to get the answer. You get it? Yes. Now, so from the calculator, you're going to get the value of y. Y is equal to you go to 6.39. Another answer will give us minus 9.39. Minus 9.39. Yes. Now, but because this one was not specific whether y is an acute angle or not acute angle. So because of that, I'm going to choose the two answers as the answer. Now, I'm not coming to teach quadratic here. Please go and solve because I have to use the almighty formula here and there. I want to give you the concept. Yes. So when you point this on calculator, you're going to get this, right? So when you are solving, just go through the almighty formula or the quadratic formula to get the answer. Now, let me solve the last question. Okay, method 2. Now, let me apply method 2. No, let me use method 2 to solve for the last question. Now, the last question is sine 5x minus 20 is equals to what? Cos 70 minus 2x. Now, with this one, I don't want to go through the method 1 a formula by changing this one to sine or changing this one to cos. I want to go through straight away method using the method 2. The method 2, it means that now sine of this angle equal to cos of this angle, meaning this one is x and this one is y. When we add the x and y, it's supposed to give us 90 degrees. You get it? Yes. So I'm going to add them straight away. Equal to 90 degrees. Now, why? It's complementary angles. Yes, don't forget. Now, I'm going to get 5x. Okay, let me just write it like this. And because of time, that is what. Now, 5x minus 2x will give us what? 5x minus 2x will give us 3x. Now, we have minus 20 plus 50 plus 70 will give us 50. Now, equal to 90. You're going to have 3x is equal to 90 minus 50. 3x is equal. Now, 90 minus 50 will give us what? Will give us 40. Now, our x will give us what? 40 divided by 3. What is our x? Now, 40 over 3. 40 divided by 3 will give us 13.33. Now, this one is two decimal places. Yes. Now, so with the two methods, you can apply any of them to get the answer. Yes. I'm giving you the concept, so you can either look at it, you add the two angles equals 90 degrees, or you change one of the angles to one of the trigonometry ratios to the other trigonometry ratio by subtracting from 90 degrees. Yes. Now I'm going to give you some questions to try, and then you send the answers to me in the comment section. Make sure you can apply the two methods to get the same answer. Make sure you understand. Yes. Now take this one and then solve it for me. Now just put your answer in the comment section. Now so try. Now the first one, find the value of y when the angle y is between 0 and 90. Now when you say angle y between 0 and 90, it means it's an acute angle. Now so we are going to find the first one, sine 50 equal to cos y. Now the second one, we have cos 2y plus 40 equal to sine 40. Now the third one is 3 sine 50 divided by 4 cos 40 plus 2 cot 30 divided by 7, let me say 7 tan 60. Now don't forget that I've talked about this one, that the cot and then the tan are also complementary angles. Now solve this one. Send the answers to me in the comment section. Yes, let's make the comment section. Yes, just question 1, you put the answer there. Question 2, you put the answer there. Now with the question 3, either question 2, you are going to evaluate this one. Yes. So put the answer to the next question. Now let's move on to the next subtopic. I'm going to explain it one by one. See you in the next video. Bye.